Hey guys, what's up?
Yes, sir. Afternoon.
You man, how going? How things?
Yeah. Not bad, you know.
How the completion of the work on Erica looking for you guys?
Well, remember I did, well, maybe I need to recheck mine, but remember I did complete mine so far.
Yeah, but I remember me also reopen something when I see you get a 93% on. And you do
Oh,
something like 93, I'm gonna reopen it one more time.
all right, man, I forgot to check it again. Thank you, sir.
How you
Alton,
doing, sir?
what you see, Alton?
I started in a sir. I had some setbacks, but I'm actually working at it.
Yeah, please. It's time is against us in terms of you completing. I know I have
Yes.
two students now in the class that have completed.
Yes.
He's been one of those, and I really want to see the rest of you. So far, I have of the seven of you, I have I think maybe four, if not five. I'm just checking that have actually started the assessments. There are some students who have not yet started, and wondering, yeah, wow, I'm wondering if they are still a part of us. Um, it is going to be a rough one. Now, there was something else that I kept saying last week that I did it to, but I never did it. Which topic was that again? I'm trying to remember.
Taylor.
Taylor.
Taylor's.
Oh, yeah. Um, um, let me just check on something here. All right, so, okay, Marie, so you're not bad. Um, I'm seeing those pieces. Yes, I did reopen that one. I mean, you don't have to do it overnight at a 93%, but if you can get the 100, why not?
Yeah, man, sir, I still going to try. Thank you.
You know, I see where it is that you I see where you all right, so one, two, three, four. All right, so five students have tried, have attempted, with two completing the stuff. All right, so what we did last class? Anybody can remind me?
I think it was multivariable functions.
Yes, yes. Did I send you anything at all? Oh, Jesus.
Let me double check and see. I think
Tell me,
So,
tell me.
yes, sir, I did.
I
I
did.
did.
Oh, good. Okay, good. Because um, I, I, my headspace sometimes, and especially that I wasn't feeling too well. So, were you able to do the questions that I sent off, or the question that I sent off to you?
But it was the same sheet that they were going through in class, so I just review it. It was kind of like revision from
Okay.
class.
So you're saying to me then that I didn't get a new question to do?
I don't know if there was any questions on it that they never give in class as a thing, but
All
as I
right.
said, I just review it.
Fair enough. Fair enough. So what I'm going to do now is right, hold on. Let me just respond to this message one minute, please. All right, I'm trying to find. I know I didn't know. Okay, let me go. Let me go here and see if I sent myself some. I sent myself some notes, but what I did was to transfer my information over to another phone. So I'm thinking that in the process I may have lost some stuff. So let me just. It is. Okay, but I'm seeing it. All right, so I'm seeing it here. All right, hold on. Can somebody share the last document that that I sent for you, please? Because now we're not sharing. Just share for me, please. Somebody, anyone of the two of you.
I just sent it to the WhatsApp, sir, in the group.
Yeah, okay. All right, great, thanks. Multivariable functions. All right. Now remember what I sent. So remember last class now, I only gave you the 6 things to find. I didn't give the full question. All right, good. I am right where you are now. How you feel about the multivariable differentiations? Do you think that you can do a question comfortable with this calculation now?
Yes, sir.
Mommy, so you stay, Papa.
Sir, hold on. You were saying how you feel about the multivariable?
Mm-hmm.
I think I feel alright with it. Feel confident enough with it.
You feel confident enough?
Yes, sir.
Nice. I love that. I love that talk. All right. For me, what I want you to do, since you guys have been the most consistent, when you cannot feel me, you know. All right, so I'm coming for you guys, literally. And if you want to call that a threat, I have no apologies. I don't care what the grade is, as long as it's a passing grade. Somehow my notes is not relating. All right. Somehow the notes don't want to populate there. Let me try it here. And I say whenever time I come to class, and I have to have multiple documents because.
Sure, excuse me 1 minute, please.
Sure. I have to have multiple documents because sometimes they just decide that they're not opening it. All right. Let me try this one this time and see if this one will come up. So, with this, goodness, I have to see if Zoom will finally connect me to. Because we're not connected to the system that I am connected before, so I'm going to log you out from there. Don't log me out. I want to sign on in 2 different places. All right. Give me a minute here, signing on again. All right. It's not. From this morning, I've been having challenges with my computer. It's just not. I guess the computer is saying that I'm tired and I need rest.
Well, I know the computer feel.
Trust me. I'm right there myself too, but it's not behaving at all. Not behaving. Computer, come on. All right. And all I want to do is just to show you guys something and give you some questions. All right. Unplug that. So just in case, that is what is causing a problem. So just in case. Choose an account. Why is it that it's doing that to me? All right, let me try it this way. Let me try it this way and see if it works. Nossa. Guys, it's I'm gonna get rid of this thing once and for all. What is it? All right, so okay, so why can't I connect to Zoom? Let me do it manually. Let me do it manually. Let me do this thing manually. But I was on Zoom for my 8 o'clock class this morning, so why am I not able to connect now? This is what I want to find out. Join a meeting. All right, let me try this one, see if it works out. I was using the computer this morning. Marking, yes, with a little problem. But I never took this long to sign on. All right, let us try this one. 979 2311 8023. All right, meeting code. Meeting code 4UQ 4UQ BSH ATGO ATG. Is that a O or zero? That looks like a zero. Finally. Wow. Okay, so you said that you're logging on and now you're taking forever to go in. All right, let me just talk to you about this thing here. In the meantime, it's taking a while to go through. It's well, the system freeze up. All right, write this function down for me, please, and I'm going to ask you in the meantime to see. I get disconnected. Write this from the other device that is. Write this function for me, please. Can you hear me?
Yes, sir. Yes, sir. One, let me just get the paper.
Yeah. I was just logged on using the other device that I want to share from, and then I got kicked off. I don't know what is happening. All right, we still have a class, never mind. When you get the paper pop, let me know.
Yeah, man, already know, sir.
Write for me. C, open bracket, C as in cat, open bracket, X comma Y, close bracket.
Hold on, you said X over Y?
X comma Y.
Or X comma Y, okay.
Right, close bracket. Say C, open bracket, x comma y close bracket, is equal to 2x squared, 2x squared
Yeah.
plus 2xy,
Plus what?
2xy
All right.
plus 3y squared minus 16x minus 18y plus 54.
X.
Read it for me, please, Maurice. I mean, hear what you have.
All right. So is C open bracket x comma y close bracket equal 2x squared plus 2xy plus 3y squared minus 16x minus 18y plus 54.
All right, great. Anthony, you got that?
Yes, sir. I
All
got
right, do me a favor. In the meantime, hopefully the computer will come up by then. I want you to go ahead and do the 6 calculations as I tell you always end up doing. And then now what I'll do, the aim for today's class is to teach you the other section of it. So you're going to go and find C subscript x of xy. You're going to find C subscript xx of xy, C subscript y of xy, C subscript yy of xy, C subscript xy of xy, and C subscript yx of xy. Whenever you get a question on these multivariable functions, those 6 calculations you will end up having to do. So again, I'm going to give you about 5-10 minutes. Hopefully by then the system will come up. Okay, it's coming up now. Anyhow, still not up, but anyhow, go ahead. Hopefully by then it will come up fully that I can share, the how it is that the question will be presenting itself. So use that function. Take about 5-10 minutes thereabout to just take your time to make sure that you get the calculation done. If you finish beforehand, I'm right here. Just say, sir, I'm finished. Start for me, please.
Okay. Finish, sir.
No man, you look like you're ready for the exam, man, because I know the computer no come up, you know. No man, you're ready for the exam, Maurice, are you still?
Well, I believe I finished too.
Right. No man, guys, I love the sound of that. It just, I'm here waiting on the computer, it not come back up yet. And you see, finish, that is very good. And I'm afraid to shut it down because if I do, it may not come back up. All right, I'm going to. There's another way. Hold on. There's another. Right. And just at a haha moment, let me see if I can do it from. Let me see if I can do it from here. And if it will work. I just need to copy a document. If I can copy to. If I can copy to WhatsApp, then I can just use it to. All right, you know what needs to happen? You guys have to go work with me. I know you guys know how to do the thing, but I want to show you. I can't. Clearly, I'm not going to be able to show you today because the system is acting up on me really bad. What is that for C of x? C subscript x of xy. Come on, take it.
C subscript x of xy.
Yeah.
I get 4x plus 2y minus 16.
That's so good.
That's good. Maurice, nice. Very good. What do you get for xx?
4.
4.
Very nice. What do you get for C subscript y of xy?
2x plus 6y minus 18.
Maurice?
2x plus 6y minus 18. Yeah. Same.
Good job. What do you get for yy?
16.
Oh, 6.
6.
6.
Oh, I get 6. Oh, hold on. You see what I made him write something wrong. I done something. And me. Alright, that's 6, yeah.
Okay, thank you, please. Very good. 6. What do you get for XY?
I got 2.
We get Maurice?
XY.
Mm-hmm.
Yeah, hold on. That would mean I did something wrong. So let me just recalculate something. Yeah, it would be two. It would be two, sir.
Right. And YX is?
Oh,
X is also two.
Very nice. All right, very, very nice. What I want you to do, as I said before, I don't know what is happening to my system. I can't share. So I will see how best you can listen to what I'm saying and perform the calculations. Now, what we're trying to do is to find stationary points. We're trying to work out some stationary points. Now, when you're working on stationary points, you would have already done calculus 1. So when you're working on stationary points in calculus 1, you are going to set dy by dx equals 0. Your first differential, you are setting equals to 0. Let me ask you, which ones are your first differential in these that you just did?
that would be C subscript X of XY
Mm-hmm.
and C subscript Y of XY.
Atom, that's very good. That's very good. You have been already, Atom?
Dinner, not even lunch yet.
Good. Don't eat no lunch before the exam here because you're firing on all 6 cylinders. Very nice. Very nice. Right. So those are the first differentials. Very nice. Very nice. Really, really proud of you. Those are the first differentials. So what I'm going to ask you to do now is to set those differentials equals to 0. So that means you're going to have 4x plus 2y equals 6, sorry, minus 16 equals 0. And you're going to also have 2x plus 6y minus 18 equals 0. You're setting those two differentials to equal to 0. Question, do you remember how to solve two equations in two unknowns? What method do we use? How do you solve two equations in two unknowns?
Simultaneous equation.
Oh, fabulous, fabulous, fabulous. I'm gonna ask you to give an attempt to a simultaneous equations. I'm still trying to fix the system because I have it here to show you. I'm gonna ask you to give an attempt to solving those two first differentials simultaneously for the values of x and y, and then I'll show you how to take on the steps. So the first part of the calculation, right there and then, straight up, out of about 20 marks, you go on 5 or 6 marks already for doing the first bits of calculations, right? So already on paper, you have those 6 marks. You have those 6 marks on paper. So all we need to catch now is 14 more marks. And the 14 marks, after 14 marks, you can catch about 7 just to do the simultaneous equation, or maybe 5 to do the simultaneous. And then the rest of them is going to be how it is that you use the answers from the simultaneous. So try solving those from the simultaneous for me and tell me the value of x and y while I try and navigate myself through solving this issue. All right? Very good, go guys. You're doing very well. Excellent. Understand?
I'm going to try a thing this, sir. I'm telling the simultaneous equation.
Maurice, what is the
Try to, you know, about kind of stuff. It's still a try.
Right. I'm being very hopeful. This one here look like it went through. For finally, I'm in. Look at this. Just look at your screen 1 minute. Oh, Jesus, this took a while.
Yes, sir.
Right. So now, see, you have all the differentials up top, and very good. So you know, separate the ones, the C subscript X in blue and the C subscript Y in blue, because those are my first differential, first order differential. So when I put those there, what I'm doing now, I'm setting those equals to 0 because I'm going to set my derivative equals to 0 in order to work my question. So I'm setting my derivative equals to 0. So I'm going to say 4x plus 2y minus 16 equals 0, see to yourself. And then I'm going to say 2x plus 6y minus 18 equals 0, see down here. So I'm going to rearrange and just keep my x and y on one side, and the constant I'm going to put to the right of the equal sign. I'm doing the same thing here. So I'm going to say 4x plus 2y equals 16 right here. You understand how I get that?
Yeah, yes, sir.
Yes, sir, but I was actually doing something different. I think I was trying the elimination route by
which is what I'm doing. But before I go to the elimination, I have to first do some rearranging.
Oh, I didn't rearrange that. I think that's what threw me off, because what I had my equation 4 would have been 2 times 4x plus 2y minus 16 equals 0, and then I'd multiply the equation 2 by the 4, multiply 2 by 4, and then minus. I think that's what threw me off.
Right. So when I set these, equals to 0, I'm going to rearrange to give me 4x plus 2y equals 16 and 2x plus 6y equals 18. Now, this is how you normally work your simultaneous equations. Then now, as you correctly stated, we're going to be using the elimination method. And the elimination method says, I need to do some levels of rearrangement so that I can go ahead and eliminate one of the variables and work the other variable. Let's go. So what we're doing here now is I'm multiplying equation 2 by negative 2. So why are you multiplying equation 2 by negative 2? I'm doing that because what I want to do is to eliminate my x's. So when I multiply equation 2 by negative 2, I'm going to say 2, I'm leaving equation 1 as it is. And when I multiply equation 2 by negative 2, I'm going to get negative 2 times 2 is going to give me negative 4. And when I get a negative 4 here, what it means that I'm going to do, when I add positive 4 to negative 4, I'm going to get 0. I'm going to get 0. And of course, it's not just the first piece that I'm going to multiply by negative 2. I'm multiplying through the equation by negative 2. So negative 2 times 2 is negative 4x. Let's go again. Negative 2 times 2x is negative 4x. And negative 2 times 6y is negative 12y. Equals 18 times negative 2 is going to be negative 36. So this now becomes my equation 3. What I'm going to be doing there, I'm going to be adding both equations to eliminate the x's. Can you see that I'll be able to eliminate the x's because I'll have positive 4x minus 4x. When I add those two equations, I'll get rid of the x's. Can you agree with me?
Yes, sir.
Now, when that is done, I can just add these and subtract the rest. I'm adding everything. So 4x plus negative 4x is 0. 2y plus negative 12y is negative 10y. See it right here, so negative 10y. And 16 plus negative 36 is negative 20. See it right here, so negative 20. Then what I'm going to do is to divide both sides by negative 10. So y is going to be equals to 2. Look at it and tell me if you agree.
Sir, repeat the last part that you said.
Repeat the last part.
Yeah, like you said, I never catch it with this way. When you say
right. So I'm dividing both sides by negative 10.
Dividing both sides by negative 10.
Right. Equals negative 20. So I do some adjustments there. So I'm dividing both sides by negative 10. And when I do, I'm going to have negative 10 cancels. I'm just going to have y left. And negative 20 divided by negative 10. When I divide two negative numbers, I'm going to get a positive number. So negative 20 divided by negative 10 is positive 2. It's positive 2. So y is going to be equal to 2. When I get the value of y to be equal to 2, I'm going to substitute y equals 2 into any one of the two equations that I started off with. Any one of them. And work out the corresponding x value. So I selected, let me see which one I selected. I selected equation 1. I've selected equation 1. Now equation 1 sorry, I'm just making this thing a little easier for you guys, so I'm just doing some adjustments over here on. So recall equation 1 given by equation 1 is given by 4x minus 4x plus 2y is equals 16. So anywhere in that equation, I see, I don't know that one, I don't want it to look like 14. Anyway, in this equation, I see x, I see y, I'm going to put 2, sorry. So this is 4x right here, plus 2 times 2, plus 2 times 2. Because this 2 times this 2 is going to give me a 4. So I'm going to have 4x plus 4 equals 16. I'm subtracting this 4 from both sides, and we have 16 minus 4 is equals to 12. So I'm going to have 4x equals 12, x is equals to 3. X is equals to 3. All right? So I'm showing you here that I use equation 1 and I got my answer. If I had used equation 2, I'd have got the same answer. If I'd used equation 2, I'd have got the same answer. Equation 2 is 2x plus 6y equals 18. See here? 2x plus 6y equals 18. And if y is equals 2, anywhere in the equation I see y, I'm going to put 2. So 2x, I write it back. Plus 6 times 2, see here, so 6 times 2 equals 18. 2, 6 is 12. When I subtract 12 from both sides, I'm going to get 6. I'm going to divide both sides by 2, I'm going to get 3. So whichever one I use, I'm going to get x to be equal to 3. And when x equals 3, now I have my critical value. You should remember this from calculus 1. So now I have my critical value. My critical value is going to be written in the form x comma y. My x value is 3. See here? And the y value from here is 2. So 3 comma 2 is my critical point. So let me tell you explain what the question is saying now. So all I gave you, and this is a past paper, 2012. The annual labor and automated equipment cost in millions of dollars for a company's production of television set rather, is given by the function here, where x is the amount spent per year on labor, and y is the amount spent per year on automated equipment. So you know that this is a multivariable function in x and y. X is representing the year spent, the amount spent per year on labor, and y is the amount spent per year on automated equipment. One is labor, the other one is automated equipment. Both of them in millions of dollars. Determine how much will be spent on each per year to minimize this cost, which implies that $3 million is going to be spent on labor. Remember, X is labor. So that's why I said $3 million to spend on labor. Y is automotive equipment, and $2 million is on automotive equipment. Do you remember that the question said both in millions of dollars? Say yes or no.
Yes, sir.
So the 3,2 is going to be representing $3 million for the labor and $2 million for the automotive equipment. And then we're going to classify those points. We're going to classify. But before we do that, are you with me so far? Are you understanding? Are you? How do simultaneous equations look to you?
Which is so far, sir. Just I might need to brush up a little on my simultaneous equation.
All right.
Same with me, sir.
All right, no problem. So you think I can move on then?
Yes, sir.
Yeah.
All right, good job. I want to move on. I'm going to tell you why. not that I don't want to spend the time working this stuff with you, but I want to finish off the question and then give you an opportunity to work as simultaneous on your own, now that I've worked through this one with you. So that's why I want to move on, to give you one to try on your own. The topic here come, so I need to spend as much time on it. It is coming. All right, so watch me now. So we are saying that, well, not we, the question tells us that we need to determine how much we spend on each year to minimize this cost. So we are saying $3 million to be spent on labor and $2 million to be spent on automotive equipment. What is the minimum cost? Oh, so the material says something on minimum. What is the minimum cost? We don't know, we need to find out. So we need to classify the above critical point. This formula in pink is the formula we're going to use. D of A comma B. The formula that we're using is f of xx AB times f of yy AB minus f of xy AB, or squares. What it means that, look at what I did. I took out my C of xx, my C of yy, and one of my C of xy. I could have taken out the yx also, you know, because remember xy and yx are the same value, true or false?
True.
Yeah, man.
True.
C of xx and C of xy and C of yx are two are the same. So watch me now. So of the 6 calculations that you did, and I want you to work with me, of the 6 calculations that you did, the first 2 that we used were C of x, C subscript x of xy, and C subscript y of xy. We use those, we're done with them. We're going to have 4 more something leave. The other 4 more something, 2 of them are the same. Talk through.
Sure.
Yeah, man. So we're going to forget one of them and just carry one. So we're going to have 3 more something to use. See them here? 1, 2, 3. C of xx, C of yy, and we're using C of xy. Then so we're going to use C of yx. It no matter, because the 2 of them will always be the same value. All right? Okay. Now my thing is not responding. Let's hope it don't cut off. All right, cool. Come back. So we're putting it in the formula. Watch me, please. This question is easy. I will find one where it is that you have to do a substitution, but this one is pretty easy. Look at what is happening. C of xx corresponds to the same thing as f of xx. C of yy corresponds to the same thing as f of yy. Same correspondence. Watch me. It says D of 3,2, because 3,2 will be our critical point. So I'm making the substitution 3,2. F of xx of AB, f of xx of A comma B is going to be my C of xx. So it doesn't matter if this is pi or A or whatever. What is important is the xx. So my xx here is 4, so I'll put the 4 right here. So this dot means that it's being multiplied. I'm looking at my yy. My yy right here should say that is 6. So it's 4 times 6 minus f of xy, which is going to be 2. So it's going to be 2 squares, because I have 1 square here. So that's why we have a 2 squared right here. So and 6 times 4 is 24. And 2 squares is 2 times 2 is 4. So 20 minus 24 is going to be positive 20. Now, once we have a positive number for D, suggests that we have a relative minimum. Why, sir? Because if D is greater than 0, if D is greater than 0, I'm just waiting for the thing to come up. Trust me, guys. You know, from when I finish scrolling, system now working with man. All right. If D is greater than 0, remember what D is, D is going to, let me see if I have it up top. So what D is AB equals f of x of AB times f of y of AB minus f of xy of AB all squares. Now, when you get D, remember we just calculated and got D to be 20, positive 20. So it says when D is positive and f of xx is also positive, you're going to have a relative minimum. When D is positive and f of xx is positive, you're going to have a relative minimum. If D is positive, but f of xx is a negative value, it means that you're going to have a relative maximum. You're going to have a relative, and if D is negative, if when you evaluate it and look at D to be negative, don't worry about it. Once D is negative, we have a saddle point. Once D is negative, we have a saddle point. So we have one where D is positive. When D is positive, we have to check to see if f of xx is positive. If f of xx is positive, then we have a relative minimum. Watch me. Positive, greater than is positive, greater than is positive. So positive, positive, relative minimum. If we have this one being positive, but the other one is less than, which is negative, then we have a relative maximum. If D is less than 0, we're going to have a saddle point. And if D is equal to 0, we're going to send back the question to them because the question can't work. Right? So what I'm saying to you is, all right, so I'm lost. No. What I'm saying to you is, seeing that D is positive and f of xx, so the xx one is also positive, it means that we have a relative minimum. It's positive, we have a minimum. If D is positive and f of xx is positive, we have a relative minimum. If D is positive and f of xx is negative, we have a relative maximum. If D is negative, we're going to have a saddle point. If D equals 0, question can't work. Hey, sir, will they give you one where D is 0? No. Will they give you one where D is negative? Yup. And if they give you one where D is negative, they will also give you one where D is positive. So just remember, once D is positive, you may have a secondary test to do. D is positive, but f of xx is positive, you have a relative minimum. D is positive, but f of xx is negative, you have a relative maximum. D is negative, you have a saddle point. D equals 0, can't work, work.
Sir, hold on, you're so far, sir.
And I'm the same to you. If D is positive, you have a secondary test to do. You have to check the value of f of xx. If f of xx is positive, then you have a relative minimum. If f of xx is positive, negative, you have a relative maximum. If when you evaluate D, and D comes out to be negative, you have a saddle point. If when you evaluate D and the value of D is 0, then you're going to have a challenge working the question because you can't do it. Question can't work. All right? So now, having worked, I think, at D to be a relative minimum, we knew that it was going to be a minimum, you know. We knew it was going to be a minimum. Why? Because the question did say, determine how much will be spent on each year to minimize this cost. To minimize this cost. To minimize this cost. And it did ask what is the minimum cost. So we knew that it's going to be minimum. So when you work it out at a minimum, you're not surprised. I mean, it's supposed to be minimum. If when you work it out at a maximum, then we don't have a problem. Now watch it. The question is not asking me about this maximum cost. Not a problem. We're going to find the original question. The original function. The original function is what we're finding. And in the original function, anywhere you see x, you substitute 3. And anywhere you see y, you have to substitute 2. And you're going to work and come down with one single answer. This answer is 12. But remember, you know, everything is in millions of dollars based on what the question gives. So the minimum cost is going to be $12 million. That's the end of the question. But this is what I want you to do for me. Having worked out the simultaneous equation and got your 3,2. I want you to write out from here. So the value of D, and you substitute that, and you get the minimum. And I want to get the practice of substituting here. So this is the end of the question. And at the end of that question, I'm going to project another question for you. So go through this, write it down for me. While you're writing it off, look to see if you're understanding what it is that you're writing off. So once you understand it, let me know. If you don't understand it, still let me know so that I can, go through it with you, and then I'm going to give you one to do on your own. Start for me, please.
Sir, wasn't on fairly cool.
Yeah,
Yeah, so we're supposed to write all this, right?
yeah, just write it off and try to go through it as a write it off to make sure you understand it, and I'm going to give you one to do for me.
But sir, one thing though.
Mm-hmm.
Uh, well, I would need to get from up the top where I do the simultaneous equation.
Mm-hmm.
As in, I would need to write out that as
Oh,
well.
oh, 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 got you.
Yeah. Yours. All right. Thanks. Yeah.
Mm-hmm.
All right. You can scroll down, sir.
Oh, you stay, Maurice, so I can scroll down more.
Sorry, say it again, Papa.
No, I was checking it, Maurice, to see if he's finished writing, so I can scroll down.
Oh, Maurice, you finish writing, I can scroll? Maurice long. All right, let me scroll since Maurice not there. That will be the end of the question.
Okay, I was finishing writing after.
Cool.
Okay, sir.
Wait, hold on, sir, hold on.
Oh, yeah.
Let me know when you finish, Maurice, and then I can project the question. All right, Alton, I hear that you finish. Let us wait on Maurice, and then we project the new question.
All right. All right, I finished now, sir.
All right, got you. Got you. Aha. Here goes a question. Here goes a question. I want you to work through, and that question, a full mark question. Something like this me expect. I want you to work through that question for me as best as you possibly can. and then I'll go through the solution with you. All right? Start for me, please. You guys are doing pretty well. It's just really the two of us mainly, and you guys are doing pretty well. So continue and just push through. These two shall pass. 2 more weeks, and then you're doing the exam and done. All right, go on, start.
So
Sir, Alton, same internet gone.
Yeah, I just saw that a while ago that came on my phone that he has in thing there. Yeah. It's all right. Just go on read. Your responsibility now is to make sure say you catch it, to teach him because it's 12 now. All right, so go on read.
All right.
Mm-hmm.
All right. Sir, what I did know? Because I realized is like the same equation as the last one, but although some of the questions different.
All
You
right.
hear me? So
Press
Sir,
pause.
sir?
Yeah, you're back, Alton?
Yeah, I just get back. It's raining where I'm at. I don't know if that's what got an internet to chip out.
Mm-hmm. All right. Now, so what Maurice was saying is that, sir, is the same function like we got before, but the question kind of look differentish because the first one had 2 parts to the question. This one has 3 parts. Why I'm doing it? Because I want to show you, whenever I take questions from the past paper, I've always indicated that I don't make it come across like my own questions. When I have my own questions, I can say, I was the one who wrote this question. I am doing this, and I'm going to tell you why. Because sometimes, I was about to say CXC, CCCJ repeats your question. No, watch me. Up here says Calculus 2, past paper, 2010, May 13. Up here, so the past paper, 2012, May 17. So exactly 2 years after we have given this very question with the same function. What am I saying to you? I cannot tell you that come 2022, that the mandem will give you the same function with a different word of word. I don't know if you're getting what I'm saying.
Yes, sir. Because when I was looking at it,
Yes,
I was even saying to myself that based on part 1 of the question, it's like it's telling you that X is 1 and Y is 3.
Very good.
yeah, that makes it too.
That's exactly what it is. You notice in the first question that we did, we had to find what X and Y was.
Exactly.
Yeah.
Right. But now it says, find the total cost in a given year. Yes, ma'am. So I am giving you, as matter of fact, I have taken off all the questions from the past paper that I give I did them and I have them to present to you in class because I want you to recognize what is possible. We are here to pass this exam and we're going to pass this exam pretty well. Sometimes the man then change the question, give it the same function, and word up is something differently. Make sure you know how to do it. But I'm not worried about you and the we call it the differentiation, the partial derivatives. Not worried about them. Just focus at what is given. You will be good to go. But nonetheless, not because it's the same question, we still will work it. We're getting into that habit. We still will work it because there's something that just comes to mind. Never have I ever seen a question on the exam paper about Hessian matrix. Never ever have I seen a question on the exam paper about Hessian matrix. And I'm going to tell you, I said to myself, really? Well, if it means this, me then change it. Me then change it. I know I wrote a question on Hessian matrix, and I want to show you what Hessian matrix is. I don't think the other lecturers have been teaching it. I don't know if them teach it or what, but I've never come across a past paper with Hessian matrix, and I'm praying to God that that question that I wrote, then put a question on Hessian matrix. So Because you're understanding this, I want to touch on Hessian matrix before we leave today. Remember, come next week, Saturday, it will be our last teaching session because exam begins on the 29th.
Yes.
Right? So next week is the last teaching session. So all the other areas that I have to finish up will be finished up. And if needs be, I'm going to call a little one class or a little one session or send you a thing into what. I'm not worried about you guys. All I'm saying to you is just do what it is that I'm saying to you. What I know is coming is a question on this. All right? So finish off this one for me quickly. Now that you know that is the same function, finish off that one quickly so that I can give you another one and then we spend some time going through some SI matrix. I will leave Taylor until that because Taylor is one of the last ones plus some differential equations and then we should be good to go and call it a day with the teaching of this stuff. All right, go, continue working. But very good observation. I was going to say it, but I said I'm not saying it. I want you guys to see it. Very nice. Continue working, guys. Well, all right.
So far, sir, I'm actually at part 1.
All right, good job.
Just calculating part 1.
Good job.
Question, sir. Hello?
Yeah, man, I heard you.
All right. My question is, I want to move on to part 2. Being that you would have gotten separate values for x and y, the critical points, and part 1 would indicate 1 and 3. Should I use the 1 and 3 to the part 2, or use the critical point? That's what I've gotten from the general question.
Yeah. Did you get 19 million?
Yes, sir.
Good. And part 2 is what it is that we would have just done. Part 2 is everything that we just did.
Okay. Oh, no, yeah. What I was checking to see is if I was going to use the 1 and the 3 for x, y values, or use the same 3 and 2.
The part 2 is, you know, doing the question based on
what it was given initially.
Right. So that's what you know. They have to throw you off because like this is a past paper question. So then things that you use 1 and 3.
Oh.
It's not 1 and 3. It is 3 and 2.
Okay.
Some students who would have recognized as a past paper question now. Would I find himself into problems?
Okay. That's what I
Alright.
wanted to
So like
confirm.
so like how you know no, like how you've already done this part one, part two, and
Yeah.
you know what to do. You kind of skip over that because it gives you parts two and three, it gives you the same thing.
Okay.
All right?
All right.
Oh,
Peter.
so you're saying, hold on, what you say about part one that is like the values them give us is to trust.
Mhm. Part one says one is 1 million, the other is 3 million. And we need to find the total cost amount. But some students who would have done the question before say, oh yeah, we get a question before, the critical value is going to be 1 and 3. But really and truly, the critical value is not 1 and 3, the critical value is still 3 and 2. So you do part one and you put on the answer there. Part two is you still going through and doing the partial derivatives and doing the question as we normally would. Follow me?
Yes, sir.
Nice.
Okay.
All right. So what I'm saying to you now, Maurice, is I'm going to forego parts two and three because parts two and three is exactly the one that the question before.
Right.
You follow me?
Yes, sir.
All right. There's a question that I don't want to give that one. I'm going to give that one is what time is it? 4 o'clock now. I'm going to give this as a take home one. There's one that came on Edico that some students asked me to work out sometime. Find the critical values of this one for me, please. And then hurry up under that, and then I move into some SI and matrix. Because this topic finished now, you know. Topic finished. When I say finished, done. Finito. Now come back. All right, try that one for me, please. A little easier because, yeah, it's going to find it and then classify it for me. I want to find and classify it. So you're going to find critical values, and I want you to classify it. Is it a relative maximum? Is it a relative minimum? Is it a saddle point? So find and classify. Quick and fast.
Look like we're stuck at the simultaneous equation part, you know, sir.
Why say that?
I need to brush up on my simultaneous
Oh,
equation.
oh.
Yeah.
I want to say you have to go stop at the simultaneous. Okay.
Oh, no.
All right, let me just go through it quickly. Look to see if you agree with those so far.
And it's minus 36, yeah. 18x, yeah. 3.
Yes, sir.
Yeah, yes, sir. Yeah. All right.
We have an issue. Say to me.
Hold on, I'm looking. Is where we get that 9 times x squared minus 4, sir? Oh.
A factor.
Yeah, I just realized. Okay. Okay. Yeah. So far, I follow.
Marie, so you still.
Hold on, I still
Take your time.
looking at that part there.
All right, Maurice.
Yeah, yes, sir. Yeah, man, you can move on.
You sure?
Yes, sir.
All right, no. So having found the values of x right there, we now need to find the values of y. So look at that one.
So we have more critical points to work with.
Yes, because it's a square term, so you can end up. So the critical values that you found here. Remember now, you have one equation in x alone. So you have, if you have an equation in x alone, it means that it's only x values alone you can get. Talk truth.
Sure.
So the values that we use when we solve 9x squared minus 36 is only x values. And then when you look at it, the second equation is an equation in y alone. So it means there's only y values going to get. Talk truth.
Yes, sir.
So we got our x values to be 2 and 2, I think. 2 and negative 2.
2 and negative 2.
Right. We're going to work out our corresponding y values. And our corresponding y values are going to work out to be 3 and negative 3.
Yes.
We have to combine them now. So guess what will happen? The 2 up here, so. The 2 here, so. Going to put this 3 and negative 3. See here, so. The 2 is linking with the 3 and the negative 3 for the y. Talk truth.
Yes, sir.
So is this negative 2. That negative 2 then link with this 3 and negative 3. See here? 3 and negative 3. What I'm saying is that these two, these two values are going to link with these two values, mix up and blend up. So one of the values going to link with both these values, and the other value is going to link with the other values also. You get me?
Yes, sir.
Yes, sir.
So that's where we end up with our 4 critical values. So we have our critical points, and we're going to test each of those critical points. Now, this is where I want to get you. If you get this piece here, so my Saturday soup going to taste even nicer. What I want you to do now is you have 4 sets of critical values: 2, 3, 2, negative 3, negative 2, 3, and negative 2, negative 3. I want you to test for me and classify each of those critical values based on the classification that we have done before. D of x, y is going to be equal to fxx of xy times fyy of xy minus fxy of xy all squares. I want you to go and test those. Once it is that you test those and everything come back to what I have, we're moving on to SI matrix, and we end the class right here. So, agreed?
Okay, sir.
Let's start for me, please. Honesty.
Almost through, sir.
All right, cool.
I think I'm finished, sir.
Maurice, what you stay?
Sure, I believe so too. I
All
believe.
right. Okay, so tell me, um, you're going to give me 1. Sorry, you're going to give me 2. And Alton will give me 2. For critical point 2,3, Maurice, what you got for critical? How do you classify critical point 2,3?
Oh, that would be the, sorry, that would be the minimum.
That would be a minimum.
Yeah.
Maurice, Alton, you agree? Alton.
Sorry, sir. I thought my mic was on. Sorry. Yeah, for critical point 2,3, I got saddle point.
Okay, I got a saddle point 2. All right, come, Maurice.
Oh, all right.
So we have a saddle point, you know, when
oh, sorry, the rules, I think I'm mixing that up in it.
Yeah, so that's what I'm going to read to you now. So saddle point occurs when D is negative. So once D is negative, you don't have to do nothing more. Once D is negative, you know it's saddle.
All right.
So once you get a negative value, you don't have to do no double check. The only time a double check is when D is positive. And what you're going to double check is f of xx. And if f of xx is positive, you have a minimum. If f of xx is negative, you're going to have a maximum. But once D is positive, trust me, you're going to have a saddle. Sorry, D is negative, you have a saddle point. So once D is negative, you'll have a saddle point. If D is positive, you have to do a double check. You have to check f of xx, not anything else. Only f of xx. If f of xx is positive, you have a minimum, relative minimum. If f of xx is positive, a negative, you're going to have a relative maximum. But once D comes out to be a negative value, boom, saddle point. And if D comes out to be equal to 0, there is no way you can finish working the question. All right, good. So look at it now, Maurice, and see if you agree with the negative 648. You got 648 negative, Alton, right?
Yes, sir.
All right, Maurice, look at it quickly for me and tell me that you got the negative 648 now.
Sorry, yes, sir, I did.
All right, good.
Other one, the other one is a saddle point as well because negative is the same answer, negative.
Well, for the second one, I didn't get a saddle point. I got a relative minimum.
I don't, not hearing you.
You hear me now, sir? Hello?
Yeah, you're Alton, but it's like in now, you're
Oh.
Alton?
Yes, sir.
Oh, maybe my internet went out, but I was asking you what is your critical point for 2, negative 3?
As in the answer, the relative minimum I got.
Maurice, what did you get?
got the same negative 648, which would be a saddle point.
All right, no, you're not going to get another negative 648. It's going to be a positive 648.
Positive.
Maurice, check where you are multiplying the -6 by the -3. You're supposed to get a positive 18.
Supposed to get a positive 18.
Yeah.
You see what it is that you're doing here? Look here, Maurice. What it is that you're doing here is actually substituting the values for x and y. So remember, y here is -3. So this is -6 times -3, which will give you a positive 18, not a negative 18. It's a -3 you're substituting. Talk to me.
Hold on, sir. Let me just look back on that.
Take your time.
Oh, sir, I see where I go wrong now. You know. When I put back the call it the equation, forgot to put the -6.
Oh, so you're multiplying 6 by -3.
Yeah.
Got you. All right. I do want to make that mistake for the final exam, because those are some easy points that you're going to be giving up.
Yeah, I have to go practice and make sure I don't make them mistakes. Yeah.
Because I know you're understanding. That's not even a question in my mind. I know you're understanding. But I just don't want to make these careless mistakes. Ouch. Okay. Now, for -2, 3, how would you classify that, Maurice? -2, 3, how would you classify that?
Hold on there, sir. -2, comma. You said -2, 3, right?
Yes, Papa.
Minimum as well.
What you get, Alton?
I got a relative maximum, sir.
So did I. Look again at Maurice.
Again, from it.
Maybe you have a positive 6 and not a -6 for your C of YY.
No, hold on, sir. I think we're mixing up something. Because I get the positive 648, right?
It's positive, but you have to look at f of xx.
Oh.
X would be that 18
Yeah.
times -2.
Which is a negative value.
Yeah.
Okay, sir. Okay. The rules, need to write them down.
Yeah, man. I'm going to send it off to you, but please. Matthew, since you say you get the 648, you don't get mark this, But it lose a little mark for the classification, the maximum and the minimum, and the center point them. But no why you lose only the marks there. They don't care what you want, say. I'm creating one cover full 20 marks.
Man, we need to scrape all of them, sir.
Yeah, man. Yeah. Very good, Alton. All right, let's go. Final one, -2, -3. How will you classify that, Alton?
I got a saddle point, sir.
Where you get Maurice?
Sir, hold on, sir. Hold on.
No problem.
Yeah, when I work it out back, I will get the saddle point. That goes to straight negative 648.
Good job. Alright then. How do you feel about this? Feel like we can tackle one on our own in an exam condition?
I should be able to. As I said, my only shortcoming on that was just brush up on the
Simultaneous.
simultaneous.
Yeah.
So from when I start out that part, I have no problem with it.
Yeah. And that's what I'm going to ask you to work on from in earnest. I'm going to ask you to just brush up on the simultaneous equation. I'm going to see if I can get another question and send off to you so you can work on it for me. But just brush up on those areas and you should be good to go.
All right, so thanks.
Cool.
All right, sir.
Cool. Now guess what now? 15 minutes. I'm going to use 10 of those 15 minutes to just work through a SIM matrix with you. It's not hard. It really isn't hard. But I need to just work through and maybe just give you, yeah, it's not hard. All right, so it says Hessian matrix. Hessian matrix. The Hessian matrix of a multivariable function, f of x of y of z, below, sir. You know, talk about x and y again now, so you're down to 3. Yeah. X, Y, and Z with different authors. A book writing, sir. We have different representations of them. We can write it as h of f in parentheses, or we could just go ahead and just write it h of f without the parentheses, or we could write it h subscript f. All right? All these are different authors. Authors mean how it is that you name them, you write them, you call them. All right? Organizes all second partial derivatives into a matrix. So all we are interested in for the Hessian matrix are the second order partial derivatives. All the second order partial derivatives. And we're placing all those second order partial derivatives into a matrix. Remember, matrix is singular and matrix is plural. So let us examine a 3x3 matrix. A11, A12, A13, A21, A22, A23, A31, A32, A33. Tell me, weight in the 1, 1, 1, 2, 1, 3, 2, 1, 2, 2, 2, 3, and the 3, 1, 3, 2, 3, 3 means. Look at it, hazard a guess, and tell what you think it means.
Sir, the A11 would be like, you call it the FXX, and then the A12 would be the the XY.
Okay.
So,
I'll tell what you think.
It's along that line I'm thinking. It's the subscript XX or subscript YY.
So so both of you are off. I want you to think again. Look at it. Just look at the 3 by 3 matrix given. How do you name a matrix? How do you name a matrix?
By the rows
And
and
make
columns?
very good. So which one you call first?
Row.
And then the other one you call after is the
Column.
good. Look at it and see if you can figure out. Not very difficult for you to figure out. Just look at it, see if you can figure out what they think the 1 1 1 2 1 3 2 1 2 2 2 3 3 1 3 2 3 3 means.
Oh, I think I get it.
Okay, what do you think it means?
All right, so since this is a 3 by 3 matrix, I think that the A11 would be like a subscript XX, the A12 be like a subscript YY, and the A13 would be a subscript ZZ. That's for the first row, and the same for the first column.
Not exactly what I'm looking for this first answer, but you are almost right for another question that I'm going to ask you. So look back at it again and see if you can answer the question. What do you think the A11, A12, A21, and then something means? That answer you gave me is going to be the answer for something else that I'm going to ask you shortly. Just think about it, it's not hard. Let us pick out one. Let us pick out A23. Each of those A's is called an element in a particular position. Case in point, let me use this. I was saying to another group of students earlier that math is life. Everything we do is math. Math is life. Irrespective that you may not like it, it is life. Watch me. So if you go to the dentist will say, number 15 needs to be rechecked. Number 4 needs to be filled. That language is universal. The number 4 tooth has a special location. The number 12 tooth also has a special location. So another any random something that we call. When you say number 4, special location. Number 2, special location. All right? So tell me, what do you think it is? Look at it one last time.
sir, one quick thing. The A11, but that would definitely be like F XX, well, F subscript XX.
Say it again.
The A11 would be F subscript XX, and then the A21 would be A subscript XY,
Oh, I think I know. I think I get something.
All right, hold on. Let me hear what Alton get. I hear you, Papa Maurice. Let me hear what Alton saying get.
Yeah, it seems that the XX, the YY, and the ZZ would be A subscript 11, A subscript 22, A subscript 33. Therefore, the A subscript 12 would be the A subscript X of Y, and the A subscript 13 would be the A subscript what's that? X of Y Z.
All right, I hear you. All right. I'm gonna tell you the answer again. Say Jesus and peace, sir. We never see that one day. All right. I'm gonna give you one more try. Give you one more try.
And all those figures, sir, would be the second partial derivative.
But everything is going to be second partial derivative that we use to get the Hasiah matrix. But good. So all right. So so as I was saying to you.
Oh, wait, sir. Hold on.
I see that you want to something.
Hold on, sir. X. All right. The A11 is F subscript X, and the A12 X subscript X Y, and the A13 is F subscript XZ.
Oh.
Well, that is what I come up.
And I'm saying to you, all right, so I know what you guys are doing. You're looking at the notation that I have beneath, you're making comparison. So what I'm saying to you, each of you is answering my second question that I have not yet asked. But you are eluding the first question that I'm asking. So you see what you see that is, okay, so what I'm saying to you is that you're seeing a pattern. So the pattern that you're identifying, we can't say wrong, but that is the second question that I'm going to ask you. You don't answer my first question yet.
All right.
All right, so let me tell you what the first answer is. And that is going to cost you, each of you, if I see no. Oh, by the way, I'll tell you, oh, Maurice, a flavored beer. Don't forget.
I know.
Okay. And that is going to cost you. You see, we're trading beers in the class. Jesus, forgive me, Lord. Anyhow, the Minister of Education hears that the teacher is trading beers in the class. I must lose little work. I must lose a little work.
A virtual beer, sir.
So guess what now? So Alton, you're at 0 beer. Maurice, you're at 1 beer. And because both of you didn't get this right, I am at 2 beers. All right?
All right, sir.
So let's go to this one. So you see the A11? I'm saying to you that I'm in the first row, first column, the first row, second column, the first row, third column, the third row, second column, the third row and third column. You see that?
Repeat that, sir.
Repeat that, yeah.
All right. So A11 is telling me that I'm in the first row and the first column.
Yes.
A22 is telling me that I'm in the second row and the second column.
Yes.
A31, I'm in the third row and the first column. Remember Alton say call the rows first and then the column after?
Yes, sir.
So I'm in the third row and the first column. Here, 1, 2, I'm in the first row but the second column. 2, 3, I'm in the second row but the third column. Can you all see that?
Yes, sir.
Yes, sir.
All right, cool. Now, those are very important. Just like your teeth, there is a directional count. starting from right to left. That we number, not we, because I'm not a dentist, that the dentist used to number your teeth. So they know, when them say number 16, they know exactly what they're talking about. Number 16, them know what they're talking about because these are in a fixed position. Now, when you look at my matrix H of F, my squiggly square F of squiggly Y, squiggly Z, these are only partial derivative. They are in a specific position, a specific position, a specific position. All right? Specific, meaning say, it can't move, and that's where it belongs. So watch me. So one of you said, you know what the one is? The one is going to be the XX. And I don't know if it was you or Maurice Alton that said it. And you're right. Because the one is saying that you're in. Okay, look at what is happening. Do you recognize that in, and this is where I'll end today. Do you recognize that in the first row, where you start off, it is going to be X's? When we start off with X's, so you have the delta X squared, sorry, squiggly X squared, then you're going to have squiggly Y, squiggly X, squiggly Y, then you're going to have squiggly X, squiggly Z. So in the first row, you're starting off with all X's. Look at what happens in the second row. You're starting off with all Y's. Squiggly Y, squiggly X, squiggly Y squared, squiggly Y, squiggly Z. But let me just go back to this one because you're going to have, you're starting off with X. Because in the first row, you're starting off with X. In the second row, you're starting off with Y. In the third row, you're starting off with Z. So what it is that you're going to have is X, then Y, then Z. X, comma Y, comma Z. X, then Y, then Z. Squiggly X, that's what squiggly X squared is. Squiggly X, squiggly Y, squiggly X, squiggly Z. Then, the second row we're talking is Y, squiggly Y, squiggly X, squiggly Y, squiggly Y, squiggly Y, squiggly Z. You recognize this is with X, Y, and Z?
Yes, sir.
Then the third row, you're going to start off with Z. Squiggly Z, squiggly X, squiggly Z, squiggly Y, squiggly Z, squiggly Z. Are you seeing that?
Yes, sir.
Nice.
Sure.
Yeah. I'm hearing you. Go ahead. You have a question? Talk to me. Do you have a question?
No, sir.
All right, so I'm going to end it right there, but I want to go through this again. I'm going to be sending you some stuff during the course of this week, and I'm going to tell you why I'm going to do it, and I want you to work with me. Even though your exam, I think, but I'm not going to say it because I don't know. Your exam could possibly be in the second week, as it is just now, but I don't get a copy of the final timetable yet, so it can change. So technically next week, Saturday, is our final class. But what I'm going to do in the course of this week is to send you some stuff, so at least, and I'm going to beg you, well, I don't think I have to ask you too much more. Alton, I want you to complete your assignments this week, please.
Yes, sir. I plan to take 2 days to try and get them.
Yes, man. Just cover them. And then now, if the two of them can link up, I don't know on the work schedule stay, but the pair of you have been working pretty well in class. If the two of them can link up, and what I sent through, I want to read it individually first, and then on spend a half an hour to a 1 hour link up and go through the information. What I don't understand, when you can message me, or when we meet up on Saturday, God's willing, the final class, we just run through it quickly, says the information you won't be meeting up for the first time, right? So at least it will be very close to you. What I'm saying to you for the assigned matrix, and when I work, okay, I'm not interested in doing the actual example just yet. You know why? The example is pretty similar to what it is that we have been doing in terms of our partial derivative. You know, I know that you know how to find f subscript x, f subscript x, script y, f subscript y, f subscript z, s. I didn't know you know to do it. That is the same thing that you're going to be using in order to do this stuff. The only thing that I want you to do for me is just to understand how it is that this matrix is derived. Once it is that you can derive the matrix, this h of f that we're looking at, you're good to go. That's all I want to be able to do for you. Because the other calculations, we don't know how to do it. So when you do the calculations, all you're going to be doing is substituted into the matrix. All right, so let's go. Trust me on this. When I send the notes to you shortly from now, just going to take a break after class and just get something to eat and cool out my head, and then come back and just send out the notes and the recording once it come up. I just want to get this. Finally, in 2 minutes. In 2 minutes. When you have, in order for you to derive your matrix, remember, it organizes all second order partial derivatives. Meaning, say, in the matrix is only second order partial derivatives that you'll have. Only second order partial derivatives. Only second order partial derivatives. All right? Only second order partial derivative. Only second order partial derivative. Only second order partial derivative. Get me?
Yes, sir.
Yes, sir.
All right. All right, good. So let's go. So remember now, it's you notice every one of them in the numerator have the squiggly square f, squiggly square f, squiggly square f. You see that, don't?
Yes, sir.
Good. First row is x, second row is y, third row is z. Can you see that? That's where you're starting. All right, watch me now. Let us look at the denominator. Squiggly x, squiggly x. Squiggly x, squiggly y. Squiggly x, squiggly z. Oh, sir, that's what you're saying. That you always start with the x first in the numerator, sorry, in the first row, and then you move from x to y to z. Yes, because all of here, so is going to be x, all of here is going to be y, all of here is going to be z. Right? The first row is x, the first column is x, second column is y, the third column is z. In the second row, you're going to have squiggly y, squiggly x, squiggly y, which gives you squiggly y squared, and squiggly y, squiggly z. And the third row, you're going to have squiggly z, squiggly x, squiggly z, squiggly y, and squiggly z, which gives us squiggly z squared. You see that?
Yes, sir.
Good job.
I see it.
All right. Have yourself a wonderful one. I'm not going to go through anything else. I'm going to give you a break. You did well. And then now I'm going to give you some stuff. Then we can have conversations with it over WhatsApp. All right? Have a good one.
All right, sir. You do.
Okay.
Maurice, you're in the group, right?
Yeah.
All right. Thank you.